This is an atom. No.
What are you doing here? You're not supposed to be here. Atoms are made up of 3 subatomic particles. Subatomic particles meaning particles that are smaller than the atom itself. These subatomic particles are known as protons, neutrons, and electrons. Electrons have a negative charge. Protons have a positive charge. You're probably wondering how I know this, right? In the
1890s.
Thomson discovered that in an atom there is a negative and a positive charge. About 20 years later, Ernest Rutherford discovered that atoms are mostly empty space with a positive charge at the center. There is a positive sign in the middle for a positive charge. You might ask, what's in this empty space? In this empty space, there's electrons. These electrons just sit around, right? Actually, no. Electrons are only found in specific orbits. In 1910, Niels Bohr found that out. Later in the 1920s, a group of unknown scientists discovered the cloud model. These scientists discovered that electrons do not orbit like planets. They actually just fly around the nucleus. And it is fast, as you will see in the demonstration coming next. Later on, we found out that there's electrons all around this. What this looks like is this. The E negatives stand for electrons. Imagine that this is electrons.
Warning! Warning! Do not watch if you are bothered by strobe or you have epilepsy. The demonstration coming next involves a very fast flashing light, aka a strobe light.
Lights off. This is how fast an electron moves. Lights on. You couldn't even see it. But that's not all the things in an atom. About 12 years later, Chadwick discovered neutrons in the nucleus. Neutrons have a neutral charge. Get it? Neutrons? Neutral?
Ha 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 ha.
Meaning they have no charge at all. So why do we need atoms? Take it away, Ashleigh.
Atoms are used for everything such as gold and silver. These minerals are used to make jewelry along with many other items. Atoms also make up elements. Elements are found on the periodic table. The periodic table is made up of many different elements and items. A couple of the most common elements are oxygen, carbon, and helium. Yay! In fact, oxygen is everywhere. See? Oh, wait. You can't see it. Oxygen is here, and here, and here, and over there. See? It's everywhere. Periodic table, there are 18 groups. Those groups are 1,
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18.
then there's the period. The period contains 1 through 7. 7 periods. Those are 1,
2, 3, 4, 5, 6, and 7.
So if you are asked what the element is in the 8th group and in the 4th period, the answer would be iron.
The periodic table is made up of different categories, 9 to be exact. The categories are alkali metals, which are blue, alkyne earth metals, which are orange, transition metals, which are yellow, noble gases, which are purple, halogens, which are green, rare earth metals, which are dark blue, metalloids, which are brown, nonmetals, which are red, and other metals, which are black. On the periodic table, every element has its own spot or square. There are 2 numbers, right here and right here, up to 3 letters, also known as the chemical symbol. And the element name is right underneath the chemical symbol. The atomic number is used to find out how many protons and electrons there are. In this case, there would be 6 electrons and 6 protons. The atomic mass is used to find the number of neutrons. You find that by subtracting the atomic number from the atomic mass. In this case, it is 12 minus 6, which is 6 neutrons. Every element has 2 numbers, as I stated before. The number in the top left corner is the atomic number. The second number is the bottom in the middle, which is called the atomic mass. The element's chemical symbol is C, which stands for carbon. That is what each...
So let's make a Bohr-Rutherford model. First, I'm going to put in 6 protons. Then I'm going to do 6 neutrons. And then I'm going to do 6 electrons. 2 on the second ring and 4 on the outer ring. I'm going to show you how to make an easier Bohr-Rutherford model. Instead of writing pluses for protons and dots and negative signs, for protons, I'm just going to write 6 plus, and the plus stands for protons. Then I'm going to put 6 and a dot beside it, and the dot stands for neutrons. And then I'm going to write E negative, which stands for electrons.
Warning!
Warning! Do not watch!
Oh yeah, I forgot both of us. This is an atom. No, not that atom. The periodic...
Choose. Go.
Oh.
We'll redo that. Go. Come on, go.
Okay, wait. Go, oh my god. The periodic table is made up of different categories, 9 to be exact. The categories are alkali metals, which are orange. Shoot, they're blue.
Warning!
Warning!
Warning! Fast lights!
Don't watch if bothered by fast lights.